Good morning. Welcome to the lecture on cracking of heavy oil. In the earlier video, we had discussed about refining of petroleum. In refining of petroleum, the fourth stage is fractional distillation. So in fractional distillation, we are separating different fractions of petroleum basing on differences in their boiling point. So there we are getting one of the fraction as heavy oil. So here the heavy oil will be cracked to form gasoline. So cracking means it is the process of breaking of bigger hydrocarbon molecules into simple low boiling hydrocarbons of low molecular weight. So for example, if we take a decane molecule, so this on cracking we will be getting pentane, N-pentane and pentene. So if we take N-decane, decane will has a boiling point of 174 degrees centigrade, and these will have boiling point of 36 degrees centigrade. So coming to the types of cracking. The two types of cracking are thermal cracking and second one is catalytic cracking. Thermal cracking means here the cracking process will be carried at high temperature and pressure. Catalytic cracking means here the cracking process will be carried using catalyst. And thermal cracking is again classified into two types: liquid phase thermal cracking, vapor phase thermal cracking. And catalytic cracking is also classified divided into two types: fixed bed catalytic cracking, moving bed catalytic cracking. So we will discuss in detail about this in the next class. So now coming to the mechanism of thermal cracking. Mechanism of thermal cracking is explained as the free radical mechanism. As we have already discussed about free radical mechanism in the polymerization process, a free radical mechanism means what? Which takes place in three stages: initiation, propagation and termination. So now I will explain this mechanism by taking an example. So mechanism of thermal cracking of decane. So here the first step is initiation. So in initiation step, decane undergoes pyrolysis to form free radicals. So decane means CH3, CH2 8 times, CH3. So this on subjecting to high temperature and pressure gives pentyl radicals CH3, CH2 thrice, CH2 radical. Next step is propagation step. So here free radicals are formed. So in propagation step, the propagation will be continued until a stable free radical will be formed. That means here the free radicals will be cracked until stable free radicals are formed. So the pentyl radical which is formed here will further undergo cracking, forming propyl radical and ethylene. The propyl radical will further undergo cracking, forming methyl radical and ethylene. Ethyl radical will undergo pyrolysis to form ethylene and hydrogen radical. So here pyrolysis may take place in such a way that methane and ethyl radical may also be formed, and the ethyl radical formed will undergo pyrolysis to form ethylene and hydrogen radical. And the third step is termination. In termination, coupling of unstable free radicals takes place. Here the unstable free radicals will undergo the termination reaction. So methyl radicals will couple, forming ethane or ethyl radicals forming N-butane, CH3 is CH2, CH2, CH3. This is called as N-butane. Or the methyl radical may combine with hydrogen radical and forms methane. Another possibility is ethyl radical may couple with hydrogen radical forming ethane. So these are the possible termination products. So here what are the final products we are getting? We have started from decane, and on pyrolysis we are getting butane, ethane, pentane, methane. All these are called as the cracked products. So coming to the thermal cracking. So thermal cracking means cracking using high temperature and pressure. So earlier I told you thermal cracking is of two types, liquid phase thermal cracking and vapor phase thermal cracking. So this is the block diagram for liquid phase thermal cracking. Here the heavy oil which is obtained from refining of petroleum will be heated to a temperature of 475 to 530 degrees centigrade under a pressure of 100 kg per centimeter square. Here the cracking process will take place and the cracked products will be passed into the fractionating column where the separation of fractions takes place depending on their boiling points. So here what are the various fractions we are getting? Gasoline, middle oil and heavy oil. The heavy oil will be again subjected to the cracking, and here the gasoline which is obtained will be cooled here, and here we are getting the gasoline plus dissolved gas, and the gasoline formed will be stabilized by passing into a stabilizer. So here the gasoline, nothing but the yield of petrol. Gasoline means nothing but petrol. So here the yield of petrol obtained in this process will be 50 to 60%, and the petrol obtained has better octane rating. We will discuss in detail about this octane rating, octane number in the next videos. And the octane rating of the petrol obtained by liquid phase thermal cracking is 65 to 70. Next one is vapor phase thermal cracking. In vapor phase thermal cracking, the heavy oil obtained in fractional distillation process of refining of petroleum will be first preheated in a preheater to 425 to 450 degrees centigrade. That means here the heavy oil will be first vaporized, and now these vapors will be passed into the cracking chamber. So here these will be heated to a temperature of 600 to 650 degrees centigrade under a pressure of 20 to 20 kg per centimeter square. So the cracked products will be formed, and the cracked products will be passed into the fractionating column. So in fractionating column, various fractions of the cracked products will be separated basing on differences in their boiling point, and we will be getting gasoline, middle oil and heavy oil. The heavy oil will be again subjected for cracking process. The gasoline obtained here will be cooled. After that we will be getting gasoline dissolved gas, and the gasoline obtained will be stabilized in a stabilizer. So here what is the difference between liquid phase and vapor phase thermal cracking means, in vapor phase thermal cracking the heavy oil will be first vaporized, and the vaporized vapors only will be subjected for cracking process. Here this vapor phase thermal cracking require less time when compared to liquid phase thermal cracking, and the petrol obtained by vapor phase thermal cracking has better anti-knocking properties. Petrol obtained by this vapor phase thermal cracking has better anti-knocking properties. But it has poorer stability. In the next video, we will discuss about the catalytic cracking and the advantages of catalytic cracking over thermal cracking. Thank you.